This is for part 1 of section 4.2, antiderivatives as areas. Now what I'm going to do is I'm going to just use the basic geometry area formulas to evaluate definite integrals in this video. And in part 2, we're going to actually use rectangles called Riemann sum method to find the area under graphs. And those graphs are going to be curved, so we're going to have to use like separate pieces of rectangles, and that for me that's very different than what we are doing in this these first 5 examples. So I'm gonna divide those into 2 separate lesson videos. So in this first one, let's just go over first 5 examples. Number 1, 2, and 3 are just evaluating definite integrals using geometry. We're going to be sketching them. And number 4 and 5 are application problems. I always want to do them. So, but then the shapes that are involved here are either rectangle, triangle, or trapezoid. So those ones, we're just going to use the area formula for a triangle, rectangle, and trapezoid. But then the other part of 4.2, sometimes if you have, suppose that you have a graph that looks like that, and then I ask you to find, hey, what's the area under this graph? I call it graph, and you see how that area is a triangle, right? And we can find the area of a triangle by using that 1/2 times space times height. We can also find an area of a rectangle. Suppose that we have a line like that, and then I ask you to find, hey, what's the area in between 0 and this point? And that's just going to be an area of a rectangle. And we do know that the area of a rectangle is length times width. At most, we may have a graph that goes like that. But then I ask you to find the area in between from this point to that point. And then, well, you're looking at, you see how that's a trapezoid. But these 3 shapes, we know a formula. And I guess for the last one that I just drew, some people we can also do it by finding the area of a big triangle and subtracting the area of the small triangle. But the formulas that are involved are just triangle, rectangle, and trapezoid at most. And for graphs like, let me show you another one. What if I ask you to find an area under the curve like that goes like that? And I want the area from, say, this point to that point. And there is really no area formula that will calculate the area of this shape. Well, that's just a random shape created by this curve, right? So if that happens, what we're going to end up doing is we're going to just split this into many rectangles. And I'll tell you how many rectangles. We'll split into rectangles and find the area of these rectangles and just add them. And that's going to be called Riemann's sum method. And for me, those are just a little different than what we are doing with just triangle, rectangle, and trapezoid formula. So what I'm going to do with you in this video is just the type of problems that will just make us do area of a triangle, area of a rectangle, and area of a trapezoid. Simple functions, simpler functions. But in the second lesson, second video, we will go over the other method of splitting an area that's formed by a curve using Riemann summation, okay? So let's start with number 1 through 5 first, and then the daily problem that I will ask you to try is actually it's actually going to be based on the second method, the second lesson, the Riemann sum, but we want to do some of the basic ones first. All right, so let's get started on this. Use the geometry to evaluate the definite integral. Now, remember in 4.1, we worked with indefinite integrals, so something like this. If I gave you integral of 8 dx, and then you found the antiderivative as that's going to be 8x plus c, right? Well, today we got some numbers here and there. If you take a look, I got a number like 1 down here and then 5 there. Now, I want to first go over this integral as area under the curve, and we'll talk about how to evaluate these using, what we talked about in 4.1. But today you're going to be drawing some pictures. You're going to be drawing some pictures because integral is really area under the curve. Let's go ahead and draw some pictures here, okay? So let me go ahead and draw number 1. Graph, well, think of that as the function f of x. Let's go ahead and graph f of x equals 8, okay? I'll go ahead and graph that. It's a constant function, isn't it? So, and I'm trying to be very good with my picture today. So I go 1, 2, 3, 4, 5, 6, 7, 8. And the function, it's a constant function. It is a constant function. So what I'm going to have is like, I'll have all these points lined up at y value of 8. And not only that, it goes to the right is also going to the left, right? So that's the function. And I got that. That's the integrand right there, right? So you graph it first, and then you look at the bounds. What they want is they want the area from 1 to 5. They want the area from 1 to 5. So let me go ahead and plot some numbers on my x-axis. Here's 1, 2, 3, 4, and 5. So this is what they want. What they want you to do is find the area from this point to that point. Okay? So let me highlight this using my highlighter. Oh no, too big. All right, I'll just shade it like this. What we are doing is we're finding the area of that rectangle right there. And we do know that the area of a rectangle is length times width, right? So let's find the length and width of this rectangle. 1, 2, 3, 4. I'll say that's 4 times. The width is, that can be width, but anyways. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the area is 32. So, you know what? We just evaluated our first definite integral using geometry. Ah, how awesome. Now, I'm going to go ahead and write my final answer. Integral from 1 to 5 of 8 dx equals 32. Now, I want you to draw pictures for this lesson. Just want you to know that integral is really the area under the curve. And that is how we can use geometry to evaluate these definite integrals. And later, of course, we're not going to graph everything because we'll learn all these tricks. We'll learn how to evaluate these definite integrals without graphing. But for today, I know there are like online calculators that you can just type this in and they will find the answer for you, right? Try not to do that, okay? Try not to use all of that and try to actually draw some pictures for me because on our first exam, I will ask you to use geometry to evaluate the definite integral. And if you just say, the answer is, ta-da, 32, without including any picture or sketch, I will give you 0 for that problem. I want you to, at least in one problem, I will ask you to use geometry, and that's in those ones, I want you to actually draw shapes and find the area of those shapes, okay? All right, that one was just a rectangle. Not bad. All right, let's do another one. I'm giving you something that's slightly more challenging on example 2. Now, what's my function here? The function that I'm going to graph is f of x equals negative 1/3 x plus 2. Well, at least that's a straight line function, right? That's a linear function going down from left to right. Let me go ahead and graph this. So I'm starting at what number? 1, 2. I'm starting at 2. That's the y-intercept of 2. Now I'm going down 1 over 3 to the right. Okay. Down 1 over 3. 1, 2, 3 to the right. So I'll have a point right here. And if I go down 1 over 3 to the right again, I will have my, the x-intercept at that point right there. So let me go ahead and graph that first. A straight line going down from left to right. What shape did we just create? It's a triangle. So what are the bounds? They wanted you to evaluate this definite integral from 0 to 6. So let me see. That's my 0 point, and this is 1, 2, 3, 4, 5, 6. Now, it happened to be that endpoint, right? It happened to be that point that creates that perfect triangle. And you know, I made it this way so that we just do at least one simple triangle problem. But sometimes, you know, you're not going to get an area of a perfect triangle. You may have to just maybe go up to this point and then find an area of a trapezoid. But I wanted to do a simple triangle one first. So let's go ahead and find the area of this triangle. Area of a triangle is 1/2 times base times height, right? Half times, what's the base? Let me count. 1, 2, 3, 4, 5, 6. And what's the height? 1, 2. Therefore, the area is going to be 6. So we used area under the graph, you just say under the curve, to evaluate this definite integral. So I can say that my final answer, well, the integral from 0 to 6 of -1/3 x plus 2 dx equals what number? 6. And this is what you will get if you type it into your, you know, I think some of the TI calculators will evaluate definite integrals for you, but I want you to practice. I want you to try a couple where you have to actually use the graphs, okay? The geometry. So far, we looked at an area of a rectangle, and we also looked at an area of a triangle. How about we look at something that's not so simple? Well, let's try this one together. Find the exact value of the integral using formulas from geometry. All right. Let's sketch this. So what's the function? F of x equals, I don't like the format of it, 2x plus 3. I rewrote it. I just switched the order and wrote it in slope-intercept form. We'll graph this. Now, guys, this is just a linear function, right? So we're going to have, what? 1, 2, 3. I'm going to start at 3, but I'm going up how many? Going up 2 over 1. So I'll have my first point over here. I'll go up 2 over 1. I'll have another point right there. Maybe one more, up 2 over 1. And my last point right there. You know what? I may want to do a couple more because look at the bound. It's going from 3 to 6, right? Up 2 over 1. So, you know, it will be nice to have a graph paper here. Up 2 over 1. Dot, dot, dot. And it's probably not so accurate now because my scale isn't too perfect. But I think I'm doing a great job. Okay, so I'll just go that much and then go ahead and sketch a line. And it's also going to the left. Oh, looks amazing. Okay, so what do they want? They want the area under this line from 3 to 6. So let me find my boundary point. So here's my 3. Go straight up. Doop, 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 doop. Oh my goodness, which one is it? It's this one right there. Okay, and to 6. This is 4, this is 5, this is 6. Oh, that I stopped on the perfect spot. Let me draw a straight line up. Please meet. Okay, so you know what? This was a very good picture, and I'm going to go ahead and shade this. Shade, shade, shade. Oh, amazing. This is not a rectangle. This is not a triangle. This is a trapezoid, right? Now, you can split this into 2 pieces if you want to. You can cut this right here and then find the area. But hello, this is a triangle and this is a rectangle and add them together. That's okay. And sometimes that's easier to do. Why don't we actually do that? That sounds like a fun idea. So, what's the area of this rectangle? This rectangle has an area of length times width. I'm going 1, 2, 3, 4, 3 for the 1, 2, 3 for the length or width, and then the other way around. Ooh, let me see if I can catch this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area of this rectangle is 27. Okay. I just did it by counting my beautiful, you know, scaled, perfectly scaled picture. But if I didn't have such a beautiful picture, I can still figure out the y value of that point by plugging in 3 into the function. 3 plus 2 times 3, that's going to be what? 3 plus 6, 9. So yeah, just like how I just counted it. But you can plug in your values into your function to find the y values. We know that. But I got the area of the rectangle to be 27. I can find the area of this triangle. Let me try that. Area is equal to 1/2 times base times height, right? 1/2 times base is still 1, 2, 3, right? Still 3. Height is, now we got to figure out the distance from this point to that point. And that is 1, 2, 3, 4, 5, 6. And it looks so easy because my picture was just so perfect. But, you know, what if you were not drawing such a beautiful, perfectly scaled picture? Well, what you can do is you can find the y value of this point and find the y value of that point and subtract to find the distance, right? So what you can do is, yeah, let's try that. So what's the y value of this point? That's when yx is 6 in this function. So I can do 3 plus 2 times 6. And that gives me 3 plus, 12? So I got 15. So the y value is 15 for the one that's high up there. Now, there's really... This is not on the curve, but this is on the horizontal, same horizontal line as this point right there, right? And the y value for this point was 9, and we got that by plugging in 3 into the function. So if this is 9, I know this is also 9. Notice if I do 15 minus 9, I will get 6. And that matches what I kind of read from my perfectly scaled picture or the graph, right? So, you can do it both ways. You can actually evaluate function to find the y values and subtract and all. But let me go ahead and find the area of that triangle. If I multiply 1/2 times 3 times 6, that's going to be what? 9. So the area of this trapezoid, if you want to break this into 2 pieces and do it that way, I can do 9 plus 27. So the area is going to be 36. Let me go ahead and write that down. So area equals 27 plus 9 equals 36. So you can do this. You don't really need to come up or write the trapezoid formula. But this is one way of doing this, right? You can find the area of a rectangle and a triangle and add them together. Or you can do the area of a trapezoid formula. And let me do that over here too, because sometimes it's easier to just go with the trapezoid. So area of a trapezoid equals, you're going to have to divide by half, but you will multiply that by height times base 1 plus base 2. So kind of an old formula from our old geometry days. So that's what it is. And we got to identify everything where h is equal to this distance, and that was 3. And base 1 is how far is, how high up is this point. So let me count. 1, well, I already counted it. That was 9 right there. So this one was 9. Base 2 is from this point all the way to that point, and that was 15. And we got everything to plug in. So these are the dimensions of this trapezoid. So I do 1/2 times height is 3, and the base 1 plus base 2, that's going to be 9 plus 15. 1/2 times 3 times, what's that, 24? So if you multiply these two, I get 3 times 12, right? So half of 24. That's also going to give you 26 units squared. So yes, it's really up to you. If you like splitting a fun-looking shape, like a trapezoid, into a small triangle and a small rectangle and add the area together, that's okay. Or you can just find the area of a trapezoid by finding the base 1 and base 2, height, and then just plugging it into the trapezoid formula. That is also very good too. It's up to you. And what I don't suggest is when you are working on this homework, because I know you're going to be tempted to, I know what's available out there. Let me double check this though. Later on, we're going to move on from this area thing. Let me go and I'm not telling you to cheat or anything. I'm just gonna show you that we're gonna get the same answer. Where's my app math way? How wonderful they, what they did over here. Now I just don't know if I can. I don't know. Can I enter it over here? Do they have integrals? I don't know. Maybe they don't. They don't. Maybe I'm just not seeing it. Maybe you guys probably know more than what I know. What's out there. But I know, for example, Napoleon. I know you have this cool calculator that will do indefinite integrals. I feel so. There's gotta be it. Where is it? I don't know. Maybe I should ask Napoleon, because I saw that he has this cool calculator, which he can use in class, that does indefinite integrals. I'm sorry, not indefinite. Ah, here it is. Here it is. So I found this. I'm gonna go ahead and type this in here. What we just did. I never used this before, so I may be messing up on my entries. So 3 is the lower bound, 6 was the upper bound, right? And the function was what? 2 plus 3x. And then this was dx outside. And then if I hit enter, we better see what number? We better see 36. Ah, yes. So you know what? Later, we're going to talk about, how we can just find the antiderivatives and plug in numbers and subtract those things in another section. But for right now, I want you to, you can check your answer, but if you do your entire homework based on some kind of online calculator without really doing areas, that's not what I want, okay? So try to draw some pictures for this section's homework, and actually use geometry to evaluate these definite integrals, at least for this week, okay? Let's now look at examples, application examples. We're still working with areas of triangle and rectangle, maybe a trapezoid. But I got 2 for you, example 4 and 5, that we can do. Example 4, physical science, distance as area. A toy drone flies in a straight line and its velocity t seconds after takeoff is given by v of t equals 2t. Where v of t is in meters per second. Now, what I'm going to do is I'm going to actually be very careful with units here. And then I will show you why does these finding area business actually solve these definite integral problems for us and get us the answers that we really want. So I'm gonna haven't really been paying much attention to the units so far. I was just busy showing you how to do these area problems. So I think this is going to be a very, very good one. Why these areas under the curve will help us find what's being asked here. So let me see. Find the distance the drone has flown after 1 second. So, okay. So let me go ahead and graph that v of t equals 2t first, okay? My horizontal axis will go from 0, 1, 2. I just noticed this problem is going up to about 2. So let me just do like 1. Whoopsies. 1 and 2 over here. And these are t seconds. And on the left side, I'm going to put velocities, right? So the v of t, these are v of t. And these are measured in what? In meters per second, okay? These are measured in meters per second. And, well, let me go ahead and graph this equation, y equals, or v of t equals 2t. So at 0, it's going to be at 0. At 1, it's going to go up to 2. So I'll have a point right here. And at 2, it's going to go up to 4, and I have a point right there. So if I graph this, it's going to be a linear function going up from left to right like this. And we graphed it. Okay, so what do they want? They want you to find the distance the drone has flown after 1 second. So 1 is right. Yeah, I think I want to keep on using this picture though. Well, maybe I'll do first one in red color. So what they want is this area. After 1 second, drone will cover that much area or that much distance. And let me go ahead and find the area of that, okay? Area equals 1/2 times base times height, right? Now area is equal to 1/2 times, what's the base? Base is 1 second, right? 1 second times what's the height of this? That's going to be the V of t measured in meters per second, right? So I'm going to go ahead and say that one is 2 meters per 1 second, right? Or just second. Yeah, I can just put second. All right, if I multiply these, and didn't really pay attention to units so far, but you see what happens. The second, this unit cancels out with that second. And if I multiply the numbers, 1/2 times 1 times 2, that's simply going to give me what? 1, right? So the final answer is going to be 1. What's the unit? Meter. Okay? So by finding the area of this triangle, we figured out that the distance between the distance the drone has flown after 1 second is exactly 1 meter. Okay? Let's try B. Let's try B. So this one was A, B. Find the distance the drone has flown between 1 second and 2 seconds. Okay, so what they want is this. Draw my horizontal line straight down. Oh, you see? Whoopsies. Let me fix my picture real quick, okay? That's gonna be 2. So this time what they want is they want the area from 1 to 2. So they want this green area this time. So notice what shape this is. This is a trapezoid, right? So let's find the area of this trapezoid. And I think I want to just do it by using the area of a trapezoid formula, okay? So area equals 1/2 times height times B1 plus B2, base 1 plus base 2. So 1/2 times, what's the height? Well, height is this distance, right? That's just going to be 1. We want to still maybe write down the units carefully. Yeah, let's do that. 1 second. That's the 1 second difference, right? Times. Now, if I add base 1 and base 2, that's going to be, well, this distance, that's going to be what? 2 meters per second. 2 meters per second plus, now what about this one? If I get that value, that's going to be 4 meters per second, right? And I'll get 1/2 times, what happened? I can't write anymore. I must be low on battery. Let's see. I just plugged my pencil in. Wonder if I can see my pencil, how it's doing. Pencil is at 2%. That's why I couldn't write with it. 3%. Will you wait 5 seconds with me? I think this device charges very quick. It's at 4% because I don't want to stop right now. I want to finish this. Sorry, I should have charged it last night. 5% should be good, I think. Don't you think? Okay, I unplugged it. Okay, I'm going back here. 1/2 times 1 second times, if I add these two together, I will get what? 6 meters per second. And then let's go ahead and multiply these. The second unit cancels out, right? So I will get 1/2 times 1 times 6. 1/2 times 1 times 6 is 3, and the unit that's left is meters. So we got that the area under area under the curve, under this graph from 1 to 2 is going to be 3 meters. So I got this one to be 3 meters. And this one to be the first one that came out to be 1 meter, right? Now let's look at the very last one. C. Find the cumulative distance the drone has flown over the first 2 seconds. We really don't need to redo this all over again, right? So we know in between 0 and 1, it went 1 meter. And in between 1 and 2, it went how many meters? 3 meters. So the final answer will be, I'll go ahead and write this. The drone has flown over 1 meter plus 3 meter equals 4 meter over the first 2 seconds. Ta-da! So that was fun. That's how we can use the area to answer some of these calculus problems, right? Okay. So I got my last example, and I got that to be very similar to one of your, well, I think 3 of your homework problems. I think they were all talking about marginal cost. We'll do that last one, and then I'll come back and we'll talk about Riemann summation, okay? All right, let's look at the last one. The cost from marginal cost. The cost from marginal cost, okay. Sylvie's old cheese has found that its marginal cost, remember marginal cost, that's simply the derivative of the cost function. In dollars per kilogram is C prime of x equals this function, and this works for x smaller than or equal to 500. What does x stand for? Where x is the number of kilograms of cheese produced, okay. So what do they want? They want the total cost. They want the total cost of producing 400 kilograms of cheese. They don't want the marginal cost. They want the total cost of producing 400 kilograms of cheese. And today, we're doing this graphically. I'm going to do this graphically. So let's graph C prime of x. Let's graph C prime of x. I don't have to rewrite this. Let me just graph it. And you know what? It's not really going to be a great graph. I'm just going to go ahead and say, hey, this is my 4.25. Just a random point. But I know I'm going to go down negative 0.003 and 1 over 1 to the right. But what I kind of want to do is I just want to kind of graph it using the intercept. So how about I find the intercept first? Just want to know where this graph will touch the x-axis, the horizontal axis in this case. So let me go ahead and solve for that x-intercept by setting the function equal to 0. Negative 0.003x plus 4.25. If I subtract 4.25 from both sides, I'll get negative 4.25 equals negative 0.003x. All right, let me get my calculator and divide. Negative 4.25 divided by negative 0.003. It's not really a nice number. It's like 16.6 repeating. Ew. Okay. I'm going to go ahead and just convert this into I'm just going to go ahead and write this as a fraction. So 14, 16, and I think it's 2/3. 2/3. And 2/3. I mean, I haven't really written what do you even call this? Mixed number. We haven't even written mixed number in so long, but here it is. I got a mixed number here for you of 1,416 and 2/3. And I'm gonna go ahead and just probably put it somewhere over here. 14, 16, and 2/3 is where the y-intercept is. But then here's the thing though. Remember the domain of this function? They said this function really just works for x values, the number of kilograms of cheese less than 500. And that 1416 is way out of my domain. So, you know what? I wanted to have a graph, but this point is not really on this graph. As you see, this x value is not in the domain. So I may just mark that. I may say that, oh, not in the domain. So I should probably just figure out where I have what the marginal cost is at 500 and just go up to that point. I'll just do that. So if I plug in 500, what's the marginal cost at 500? You know, what you are seeing is me trying my best to graph something. Graph an accurate graph. So I was trying to first plot the x-axis, x-intercept, but that x-intercept was way out of the domain, so I gave up on that one. I'm going to erase that soon, but let me just at least try to figure out how far we can go. Negative 0.003 times 500 plus 4.25, and that came out to be 2.75. Okay, that's better. So I know I have a point right here, and this point is going to be 500, comma, 2.75. And I have another one up there at 0, 4.25, right? So I don't really need this black line. I know this function is defined just over here, up to that point, right? Now, what I also know is that, will this graph go to the left of 0? Can we create or can we produce negative number of kilograms of cheese? No, not really, right? So what I'm also, What I'm also going to do is I'm going to also just extend my black line, my graph, from 0 to 500. Yay! All right, so what is that? What do they want? Find the total cost of producing 400 kilograms of cheese. Okay, we'll do that. We will do that for them. So here's my 400 approximately, and I've extended my line up here, and I will shade this. I see a trapezoid. I will shade this trapezoid. And we will find the area of this trapezoid for them, okay? Oopsies, that's not what I want. So I spend a good amount of time graphing because, you know, this section is all about, guys, using geometry and the graph to evaluate these definite integrals. So if I rewrite this as an definite integral, that's going to be from 0 to 500 of this function dx. And why not later I'll go ahead and evaluate this on my handy dandy calculator just to check the answer, but I want to do this graphically. So all right, area of a trapezoid, area equals 1/2 times height times base 1 plus base 2 for trapezoid. 1/2 times, what's the height? Height is this distance, right? And that is 400 kilograms of cheese times base 1 and base 2. Base 1, I usually call the shorter size base 1, but it doesn't matter. I can say this is base 1. And how tall is that bar? That bar is about 4.25. And if I'm trying to be picky about units again, I can say this is 4.25 kilograms per what? No. What's the unit of our, this isn't velocity. What's that? The marginal cost. Oh, the unit's going to confuse me a little bit. A marginal cost means how much more money are they going to make for producing 1 extra kilograms of cheese, right? So I'll say $4.25 per kilogram plus the base 2. That's going to be this much. How tall is that one? And I need to figure that out by plugging in 400 into this c prime of x function. So let's plug in 400 into the function. Negative 0.00, whoopsies, 3 times 400 plus 4.25. if you plug in, you'll know exactly how tall that point is. So I'm going to go ahead and type that in my calculator. Negative 0.003 times 400 plus 4.25, and that comes out to be 3.05. Awesome. So at the time they're producing 400 kilograms of cheese, their marginal cost is $3.05 per kilogram. And if I go ahead and now finally multiply them, or first let me go ahead and add the base 1 plus base 2 first. So if I add 4.25 plus 3.05, I will get $7.30 per kilogram. And let's finally multiply. What unit cancel out? The kilogram cancels out, and the only unit that's left is dollars, right? So I'm going to say the answer is going to be in dollars. Half times 400 times 7.30 cents. That's going to be $14.60. So let's try to answer their question in words, okay? What's the total cost of producing 400 kilograms of cheese? It's gonna be $1,460. This was, I think, super fun. That was so fun for me. From what we just went over, you should be able to go the complete because the homework for 4.1 section, it only has 9 problems. You should be able to go up to number 6. I did want you to try these application involving antiderivatives as area. So you'll have a couple of these marginal cost function on your homework. And there's one about marginal profit, but exactly the same thing, right? So try those 1 through 6. But you want to come back and watch the second lesson on Riemann summation to try homework number 7, 8, and 9 and the daily problem, okay? But that's enough for part 1. Hope you enjoy this area business. Definitely try to graph the functions instead of... Now, just remember, I said I want to kind of plug this in to my scientific calculator. And Napoleon may want to do that too, or anybody with the TI, that calculator. We can go ahead and check our answer over here. Let me go find math. Where is my not integral function here? So let me go ahead and type in the lower bound was 0 and the upper bound was 500. Upper limit was 500 and the function was negative 0.003x plus 4.25, and then let's put in dx, where the variable of integration is x, and let me hit enter. And we got 1750 for the answer. All right, let me go check and see if we had, 1750 for our, where's my notepad? Oh no, I got 1460. What in the world went wrong? Oh my God, gosh, guys. You know what I did wrong? It wasn't up to 500, right? What was the upper limit? It was actually 400, right? We went up to 400. So when I wrote that down earlier, I was just looking at the upper limit of the domain, but it should be 400. Oh, I almost lost it. All right, let me go back up to my calculator and copy this down, but change that limit to what? The upper number should be, how do I clear this? Oh no, I cleared the whole thing. You know, guys, I thought I was good with technology, but I'm figuring out I'm struggling with these technologies. So 0 up down there, 400 up there, and for the function right here, negative 0.003x plus 4.25, and then I'm going to plug in the x in there. And guess what we're going to see? We better see the right answer. 1460. Okay, let's see. Was it really 1460? I think it was. Yes, it is 1460. So, the last part that I just did with you on my calculator app was just a check, but please, because I know if you are doing your homework and if you are simply using your, integral calculators, you would